Hi guys, welcome back. We are going to do today a bit of a look at a proportional turner which will adjust its own speed, and as it gets closer to the target it will start to slow down, and then when it gets really close to the target it'll start to go even slower. So the first thing we're going to do, we're going to drop in some variables. I'm not going to need that many this time. So we've got the first variable there, which is heading. And the next one, we're going to write a variable in logic. And the logic variable is going to be left or right. So we're going to tell it when we use this block whether or not we are turning left or we are turning right. I'm just going to grab a loop and we'll extend this loop out and make it a lot bigger so we can fit all the stuff in. I'm going to grab our heading variable. We're going to read numeric, and then we're going to grab our gyro sensor in measure angle mode. My gyro is in port 3, so I'm just making sure I'm checking that as I go. And I want to find out the difference between my heading and my gyro, so I'm going to take them away. So the heading goes to A and the gyro goes to B. The next thing we're going to do is we're going to add a proportional gain. So that total is going to come through, and we're going to times it by a small gain, so just 0.4 at this stage, to try and make it turn a little bit slower than just reading the normal errors. And you'll see what I mean when we start to trial this as we go. The last thing we're going to do is we're going to create another one here, and we're going to times by -1. So we want one wheel to go forward and one wheel to go back, similar to the way that we were controlling the line follow. But with this one here, we don't have a set speed, so it's just going to be the error that's plugging in. So we're going to take our overall difference between the two sensors with the proportional gain on it, and that power is going to go into B, and then we're going to add that gain into the times by 1 and then put that into C. Just extend it out a bit further here. So that's the first part. It's going to proportionally give itself speed depending on the error. So one wheel will get a positive value and the other wheel will get a negative value. So it should turn on the spot given the difference between those two numbers. Next thing we're going to do now is we're going to create an exit. So we want this block to finish, or we want it to keep turning for a certain amount of time. So we're going to take our gyro block down again in read angle mode. We're going to get a read numeric of heading again, and we're going to take, well, we're going to have a bit of an error leeway here. So we're going to have our heading plus 10 and our heading minus 10, and we're going to say that is our heading plus 10 or minus 10 from the overall heading. And this block here is called a range block, and it has a target, and we're going to put in here, it's going to read our gyro as a target, and then it's going to take the heading plus 10 as our lower, and it's going to take the heading minus 10 as our upper. And it's basically just saying, does my gyro read anywhere between plus 10 or negative 10 of the value that I had in heading? So for example, if I had a heading of 70, it might read that it's reading 75, or it might read that it's reading 65. If it does, it's going to exit that block because it's getting close to where it needs to be. So this is the second part now. Just drag down a variable. So I've just dragged in a logic block, which is a left or right, and it's reading logic. What we're going to do now is grab a switch, and we'll switch it to logic mode, and we'll switch it into tab view so it's a bit smaller, and we'll just connect that block up. So I'm going to extend it out because we've got to put a bit of stuff in here now. So this is the true side of our switch. So we're going to add a variable now, which is new one, and we need to call this one minimum power. And on this side here for a left turn, my motors need to go in -5 because my robot has inverted motors. So the next thing we're going to do is we're going to read that minimum power. So we'll go read numeric, and we're going to plug that minimum power now, same as we did up the top. We're going to have one wheel going forward and one wheel going backwards. So we're going to have another multiplication of -1. We're going to have a move tank again. On. And we're going to plug that minimum power value into the A of the multiplication, and then we're going to plug the output into C. We're just going to take the straight minimum power now and put that into B. So one side's going to get +5, the other side's going to get -5. The next thing we're going to do now is read our current, well, the desired heading or the target of where we're wanting to turn to. And we're going to compare or wait now till we get to that exact gyro heading. So we're going to go gyro. Oh. We'll go back and we'll change that, sorry. Gyro, compare, angle. And we're going to plug our heading into the threshold value there. And we're going to change this one to, it's not greater than, it's less than for a left turn. So we're going to plug our heading into the threshold. So if the gyro is reading anything less than the heading, it will stop and we'll turn off the motors. So we're doing this at a really slow speed, so it's going to be super accurate. The last thing we're going to do is put in a 0.2 of a second wait, and that will make sure that we're accounting for that lag in the gyro as well. So we're going to copy all the stuff we've just put in this side, and we're going to copy it now into the negative or false portion of the switch. So we'll paste it in there, drop it down. And all we need to change for the negative side is that we had, well, -5. So now we're going to make that +5. And rather than the waiting for something that's less than, we're now going to wait until something that's greater than. And that is it. So if we recap, basically what we've made, we've got a proportional controller that will adjust its own speed depending on the error at top. And it will take the heading that we want it to turn to, and it will compare it against the gyro reading. So it'll work out the difference between the two, and it'll times it by a proportional gain. It'll give one a negative version of that number and one a positive version of that number into the motors, and it will start to turn. And then what we're doing is we're doing a check. Is that gyro reading +10 or -10 from the heading? So if we had a target of 60, so +60, whenever the robot turns into, say, even if it got to 55, it would exit that, and then it would complete the rest of the turn using the bottom portion there. So it's asking it, is it a left or right turn? And it's going to turn using a value of 5. So 5 motor speed is really slow. So what we should get is that we get a really accurate turn. So what we should see is the robot will speed up to turn the first portion, then slow right down towards the end, and it should get pretty much spot on, give or take 1 degree probably for most turns depending on your robot. So give it a crack, let me know how you go.